I had several people request practice problems. So I'm going to do those first off of the practice problems exam worksheety thing. So we'll do a review, then we'll do a group quiz, right? You have your exam on Monday. You have a little bit of homework left for the rest of the semester, and then your final is scheduled for May 1st to 8 a.m. If for some reason that time doesn't work for you, time, date, whatnot, there are some options. Alright, I'm just going to work through them like first set of questions all the way towards the end. So the first question I had was number 3. Alright, so the first question, number 3, says, consider the reaction below. Determine the value of delta S to the surroundings, given that delta H is negative 1267 kilojoules, and the temperature given is 398 Kelvin. Alright, so if you're given Kelvin and you're looking for delta S to the surroundings and some temperature, what sort of equation do I need to use to get these to all kind of work together? Right? So you have this equation, and you're looking for delta S, because it seems like you don't have enough information, right? Seemingly off the bat, it doesn't look like you have all the things you need. But what is one spot you know for sure delta S of the universe could be solvable for? Yeah, right? So if we compare it to 0, we can solve for T, well, solve for a delta S knowing T and H, and then talk about above or below the temperature. The multiple choice questions refer to spontaneity or not spontaneity. So I have to be looking at where delta S of the universe is 0 and then figure out which side of it you would be on. Alright, so let's see what that is. Let's see here. Maybe 7. 7. Yeah. Oh. Sorry. Yep. That's alright. Getting ahead of myself. Otherwise these problems will be real hard. I'll give you all the constants if that's helpful. It is. It's a real one. Alright, so we find that delta S is surroundings if the universe is at 0, it's 3.18 kilojoules. So if that is the case, looking at our multiple choice options, that only leaves us with D and E being good options. What of those two is the better option, knowing that delta H is a negative value and delta S is a positive value? Is that spontaneous or not spontaneous? Spontaneous. So D is the only good option that answers everything. Well, that's a good thing too. But I'm saying working through the whole logistical thing. Yes, D is the only one that has positive 3.18, so yeah, thinking through all those options. Okay. Everyone interested in that one? I'm just kind of plugging it in. The trick is that if you didn't have it, you could at least compare it to 0. So you're at on that scale. Number 4 is a similar question. Alright, so let's say the delta H is negative and delta S is positive. What do we know about its spontaneity? Spontaneous or non-spontaneous if I have this set of parameters? Spontaneous at what temperature? All the time. Right, because exothermic and increasing entropy is like the magic combination. They'll be spontaneous all the time, all the time. Correct. It's only when you have one of each that you have to spend some time thinking about. Or maybe you've already actively learned that combination of things. If one's positive, one's negative. Yeah, it's just a multiple choice question. It was spontaneous all the time. Alright, let's take a look at 5. Alright, so given delta H is a negative 11 kilojoules and delta S is negative 17.4 joules per Kelvin, at what temperature does this reaction become spontaneous? Alright, so if I give you H and S, and I'm thinking, and you need to know about T, and you want to know about spontaneity, what is the correct equation you need to use? We use this one. Alright, so that's the only one that combines all those ideas together. S, H, T, and delta G tells you about spontaneity. This is the only one that does all of those things. So as I go to plug this in, what are some things I need to look out for? Delta G is not given. How do I figure out what I should use for delta G? It's 0, right? At 0, I'm at equilibrium. So it doesn't tell me about G, but I want to know about spontaneity. Set G to 0. What do I have to worry about when I'm looking at my delta H? Joules, right? It's given in kilojoules. Those are like the two things you have to look out for. That's it. It's a tricky looking question, but they're just asking you to plug it in and find T. And by they, I mean me. I'm just asking. I want myself in the third person-ish. Royal third person. Alright, so that's the temperature at which it can start to move over to become spontaneous. Alright, so at that point you're at equilibrium, so any temperature above that should make it spontaneous. I guess we want that. Let's see. That was 5. Alright, so that's number 8. Alright, I want to find the delta G of the reaction, given the reaction in a table of delta G's. What am I asking you to do? That's electrochemistry. The right idea. Finals minus initial, products minus reactant. Similar idea, yeah. Alright, so delta G of the whole thing is the reaction. Is the sum of all the delta G for the product minus the sum of all the delta G's of the reactant. What's the other thing you have to do just besides flat out subtracting them? Mole. It's take care of the fact that they are not all 1 mole. It's multiplied by their correct stoichiometric coefficient. So it would be something like, alright, products. Oh, wait, why is nitrogen not on my table? It's in a standard state, so what should its delta G be? 0. So it's just not on the table. So not a typo in this case. In this case, I can't guarantee that for all the cases. Do I have to worry about units? No, right? Because they're all in the same unit. Right, so it doesn't matter. I don't have to worry about joules and kilojoules. They're all kilojoules. Let's see. 4. Alright, so there's a lot of delta G equations, and you're going to want to know which one to use. It's going to be based on what information I give you. Did I give you H's and S's? Did I give you a bunch of delta G? Did I give you equations that have a delta G, and I'm asking you to rearrange it to find the new delta G? So like 3 or 4 different ways I can ask you to find the overall delta G. And you'll know which one to do based on what other stuff I gave you. I'm not going to be tricky and confusing and give you a table of G's and H's and S's. That would be, I mean, I totally could, but I'm not going to. It'll be very, hopefully, straightforward what kind of question I'm asking. Questions on 8? Alright. Well, let's look at 11 was a very popular one. Lots of questions about 11. Alright, so what am I looking for in this question? The non-standard state G. Alright, I gave you the standard state G. I want the non-standard state. How would you know you're not standard state given these atmospheres? I'm not at 1, so you're not at standard state. So I'm looking for how far away from standard state are you. There's only one equation that relates standard state and non-standard state. Natural log of Q or K? Q. Why is it Q? Because you're not standard state, and you're not at equilibrium. Or maybe you are, you just don't know you are. So Q is the safer bet. Alright, if I want to find Q, what is the equation for Q? So what is my product, the oxygen or the ozone? Ozone. Okay, what do I have to do to the atmospheres? Yep, square that. So if this then is my, what do I need to do to my oxygen concentration of pressure? Alright, so now you could have done this all at once, right? You could have solved for Q in the equation. I did it separately. Now I plug in 326 kilojoules. What's R? The gas constant, right? What's going to be an issue when I go to finish solving this now? Yeah, this one's in kilojoules and that one's in joules. So, it has to go one way or the other. Doesn't matter to me which one. Ran out of space. 298 natural log. So it seems tricky because I gave it to you in pressures, but we used them just like concentration. It just happened that I was looking at gases for my reaction. Is this reaction spontaneous as written? No. What are some things that tells you it's not spontaneous? Positive delta G. What's the thing that tells you about entropy? Is it looking good in terms of entropy? Why is it not looking good in terms of entropy? How many moles of things did I put in? Right, I put in 3 moles and I only got out 2 moles. that's an issue with entropy, right? Entropy always wants more stuff, and you've given it less stuff. So there's like two different things going wrong with this equation that makes it non-spontaneous. Is it more or less non-spontaneous than when I started? How would I know comparatively? Alright, I'm going to compare it to this. This is standard state when everybody's 1 atmosphere. Is this better or worse? It's worse. Why is it worse? Yeah, it's a higher thing, plus I have even more products than reactants. So which way does this Le Chatelier want to go? It wants to go reverse, right? It's going to want to go back towards reactants. Those are all great questions I could ask. This could be like part A, part B would be like tell me what the entropy, part C would be which direction would the reaction have to go in order to be a spontaneous reaction. I don't know if I'm going to do that, but it would be a great question. Okay. Questions on this? Okay. Let's see. Okay, so that was 11. Alright, so number 13 says determine the equilibrium constant for the following reaction at 298 degrees Kelvin. Given that set of information. Alright, what letter of the alphabet is our equilibrium constant? K. There's only one equation that you use that relates G and K. Alright, there's only one that relates G and K. Why would I use K in this case instead of Q? Because I'm at equilibrium, and I can tell because I'm at standard state, which should be equilibrium-ish, so those two should go together. For the previous one, I was at non-standard state, so I have to use Q. So you can see, like, they're very similar reactions. If you know this one, you actually do know this one, right? Because they're almost the same. This is delta G reaction. This plus this, if I get rid of that, I now have this equation. Right, they're similar in information. If you were looking at concentration-wise, but you can't do that directly because these are gases and a pure liquid, so we don't have a good way of solving for K using our regular product of reactants. Yeah. If I told you the concentrations of all these, then it'd be different, but... Anyone else with that? Good. That is a tricky thing. So officially delta G is implicitly per mole. It's just not always written per mole. For whatever reason, thermo people leave out that per mole. But as long as you know, delta G should definitely be an energy unit, and K should never have units. You can kind of work around it. Is this reaction, this value of K, telling me that it's going towards products or towards reactants? Towards products. What does the delta G tell me about spontaneity? It's spontaneous, right? Those two things, again, tell you the same stuff. It's going towards products spontaneously. So these two things should jive. If you get a negative K, somehow you've lost a negative sign, one, your calculator will erupt into flames. You try to negative E up here, you'll get all kinds of angry, overworked. But if you get a K value less than 1, use your scientific knowledge and be like, let me just double check that. Okay, delta G is negative, spontaneous towards products. Then you need to go back up here and double check your work. Make sure you got all the things going in the same direction. Unlike in a court of law, there can be no contradictory evidence in these questions. They should all tell you the same thing. That would have been positive. It would have been very, very tiny. Yeah. Yeah. Because it's telling you that there's way too many reactants, and so the fraction would be less than 1. Right? Yes. Yeah. No. Yes. Yeah. No. So K is compared to 1, but G, S, and H are compared to 0. Alright, 13 question. Towards products. Doesn't tell you spontaneous, just tells you towards products. G tells you spontaneity. Usually it's good. They should tell you the same thing. Yeah. Alright, let's see here. Alright, I would like to balance this equation in acid. Hold on. That's 15. Just kidding, 15. Sorry, I had to change, my answer key's old, and I apparently did not update all the numbering systems. Alright, 15. I still want to balance this in acid. I still would like to. Alright, do you have a preference which half you take first? Manganese or carbon? Manganese, sounds good. Alright, how do I go about figuring the oxidation state of this Mn? What do I know about the oxygen? -2 all the time. If I have 4 of them, I now have -8. So what must be the manganese to leave it overall -1? +7. I've gone +7 to +2. Is that an oxidation or a reduction? Reduction by how many electrons? 5. Alright, so that takes care of the electrons. If I'm in acid, what are the 2 things I can add to my reactions to balance everybody out? Water and protons. What should I do first? I need to add 4 waters over here. Then what? 8 protons. Now are we all happy, set, balance, charge balance, mass balance? We should be. Good. The answer is yes. The answer is yes. No one's going to answer me, so I'll go ahead and answer my own question. Oh, you're still counting, that's fine. Alright, so now let's take a look at the carbons. Of the H, the C, and the O, what's the only thing that's probably going to change oxidation state? The C, right? The C is going to change, because what do we know about oxygens all the time? They're always -2, and I have 4 of them. So what should the oxygen component count for? -8. What are hydrogens? Just about all the time. And I have 2 of them, so they're +2. So what do both the carbons count for? Overall, to make the thing neutral. 6. What are they each then? Okay, so they're each +6. Or they're each +3 altogether, +6. All right, we'll look over here. If I have 2 oxygens, what are the carbons going to be if this thing is neutral? +4. Alright, so I've gone 6 to 4. Well, +3, sorry. +3 to +4. That's an oxidation. How many electrons do I need for each carbon? 1 for each, right? Each carbon is +3. It's going +3 to +4. So I need 1 for each carbon. So overall, how many electrons do I need on my product? 2. What is the issue with the number of carbons I have over here? I am short carbons, right? I put in 2, but I only have 1. Alright, so if we double this, what should I do next? How am I looking in terms of oxygens if I now have 4 oxygens and 4 oxygens? Looking pretty good. What's left? The hydrogens. I have 2 over here. What do I need over here? Are we balanced in terms of I got 2 carbons, 2 carbons, 2 hydrogens, 2 hydrogens, 4 oxygens, 4 oxygens. Looking good? Okay. What's the charge of my compound going in? 0. What's the overall charge coming out? 0. We're good. So now, what do I need to do to recombine my equations? Yep, so this one is 2, and that one is 5. Jordan. Because, right, each of the carbons were +3, and I had 2 carbons, right? So each carbon needs 1, but overall needs 2. Because each of the carbons are +3, going to each of the carbons being +4, so +3 to +4, this one's too big by 1. So I'm going to add an electron to it. Yeah, I would say, right, because now if I have 2 carbons, I have +8 over here, right? I have +6 to +8, and then 2 electrons. That may be easier. Sometimes it's easier to do the mass balance and then figure out the electrons to make sure you have the right number of carbons and everything. Alright, I'm going to do one more so you have enough time to do your quiz. Let's see what the last one can be. Ugh, okay. No, it's alright, you're right. Alright. Alright, hold on. And that's why I stopped, because I didn't want to write it out. As long as you leave off states that matter, it's pretty quick. Not that they're not important. States that matter clearly critical, but I'll make sure I have enough time to do the other most popular questions I got asked. You could reduce this whole, you could reduce, yeah, you could cancel these out and say, no, you don't have to, as long as it's all balanced, I don't. you don't have to spend your time reducing it. Just like if this had all been like multiples of 2, we could divide the whole thing by 2, but I'm more concerned that you get the right combination of things rather than the lowest common whatever. Alright, so the only other big question I got was the one I tried to do earlier. And if I didn't get to your question, you emailed me. You can either come by later, email me. I will say, looking at your study guide, you won't be able to do 23, because that's the one topic we didn't get to. Talking about electrolytic current. You haven't done that yet, so it's not going to be on the test. Alright, so given all the information, I want you to find delta G. Alright, so that's the equation that relates G and E. How do I find E0 of the cell? What minus what? Cathode minus anode. So, up here, what element is at the cathode? Who's being reduced? Iodide, right? It's going 0 to minus 1. Right, so it must be that. If iodine's being reduced, it's the cathode. You have to spend some time thinking about, oh shoot, which one is the other one? I mean, you can slowly talk yourself through it. What's the other good thing that the fact that we're only doing voltaic cells should tell you about E0 of the cell? It's always going to be positive. We're in the chapter section that E0 of the cell will always be positive. So if you find that your E0 of the cell is negative, you've got them flippy-flopped somehow. So we're always doing voltaic cells. E0 right now will always be positive. Till Wednesday. Yeah. Oh, you're looking at this? They are always written as reductions in the table. Always, always. So it doesn't matter what they're doing down here, you have to look at the original equation. Right? Just like on the table, they're always going to be written as reductions. You have to know which one is the reduction, which one's the oxidation in your original equation. So they're always going to be given like this, either in the table or if I type them out. You do not change the signs, and you never ever multiply them. Both of those make me ragingly angry. Do not change the sign, do not multiply them by anything. Yeah. Pretty much it looks exactly like this on the table, or on the exam. I don't think I'm going to use the table, because it gives you too many hints. Yeah, like if you were doing the previous one where you're balancing an acid, if you go to the table, it tells you how many electrons and waters and acids to add. Kind of cheating. Kind of cheating. Alright, so I have enough time to give you the quiz. Right, E0 is going to be 0.544. How do I figure out what N is? It'll be 6, right? It's the lowest common denominator that combines 2 and 3. F the constant. Yeah, so I will give you all the constants on the exam. Forgot to give it to you on the quiz. I'm going to write them on the board. Yeah, sometimes it's scientific and sometimes it's not. Feel I'm a mood. Does it make sense that your delta G is going to be a negative value? Good. Yes. Yes, it does. Alright, so I will stop the video.